Go 1.24 is almost out. I don't know when it's coming out, but I think it's very soon. But nonetheless, I heard very good things about it, at least from what I read here and there. And in this video, we're basically going to check everything what's new in 1.24, weak pointers and all that shenanigans. So it's going to be amazing. I'm actually looking forward to 1.24. It doesn't really happen that often with Go releases. Generics was pretty nice. Iterators was kind of meh. But 1.24 will solve iterators. We're gonna see that right now. But before we start, guys, if you like the videos that I'm providing to you, consider subscribing. And I'm actually very curious to know what you think about Go 1.24. So let me know that in the comments. It would be amazing to see how you guys think about that. And don't forget to jump into the Discord so we can actually talk about good stuff 24/7. Links down in the description. So without any further ado, let's get started. So I have this website here, which is actually like an interactive tour from Anton Z. So good job. And let's take a look. We're gonna skip some stuff that I think is not important. If you think that's important, hey, you can just read. I will make this link also available in the description. So the first thing in 1.24 is basically generic aliases. And what this does is basically, so remember right now, if you make, for example, a type ID and you say it's an integer, right? So here you're gonna see we make a variable n, which is an integer, is 10. We make a variable ID, which is of type ID, is also 10. But then what you're gonna do here is we set ID to n, which is basically you say, hey, this variable of type ID is now a type int. And that gives you a compiler, and it makes no sense basically because type ID underlying is an alias for an int. And this was so annoying, and what you needed to do right now is basically, you guys will know it, is wrap this n with this ID type, right? You need to wrap this. And I use this all the time. It's pretty annoying. But now it's basically solved because right now the compiler understands that this alias is an int and you can just assign them to each other and it works perfectly fine. This should actually be already supported by the compiler a long time ago, in my opinion. But hey, it's now here, so thank you very much, Go team. Then we have something here which is support generic type aliases. I think this is kind of okay. It's syntactic sugar. It makes your life a little bit easier. Maybe it's a little bit cleaner. Why not? People coming from another language want to make things a little bit more clear. Why not? But here, not that it helps much. They say it themselves. But it's nice. Sometimes I do this myself, that I make type M, which is a map. So I don't need to do a map string interface. So I just make a simple alias. And this makes it even better because right now you can make a generic type aliases. I like it. Why not? The thing is that if we do not practice this when it's out and we do not remember that we can do that stuff, we're probably never gonna do it and we're gonna forget that it's actually inside of the syntax. But hey, I think it's pretty nice, right? All right, now we have weak pointers. That's actually very interesting because Golang was lacking weak pointers. Also, I think this should be in the standard library for a very long time. But hey. So what is a weak pointer? It's going to confuse everybody, and I need to be very careful that I do not confuse you even more. So a weak pointer references an object like a regular pointer, right? But unlike a regular pointer, a weak pointer cannot keep an object alive. If only weak pointers reference an object, the garbage collector can reclaim its memory. I already read a bit through this example, and I don't think it makes... Well, it makes sense, but it's hard to understand for people, especially if you never actually needed to deal with a weak pointer. But in my understanding, coming from another language, a weak pointer is actually very simple, right? So, for example, let's say you're gonna have node 1, right? I'm gonna make this very simple, so please don't pitchfork me on Reddit. Node 2 happens all the time. So node 1, node 2, and let's say you have some kind of a linked list, for example, and you're going to say that, okay, node 1 next, right? I don't know if you know what a linked list is. Probably you do, and if you don't, you need to check that out. So if you call next is going to be a pointer pointing to node 2, right? And node 2 is going to have a parent, for example, or pref or something, or a parent. Let's call it pref, I would say, pref, and that's node 1. So if these are pure pointers, regular pointers, the problem is that we can never clean them up because they still hold reference to each other. It's based with the reference count and all that stuff. So you can never clean them up, right? Is that dangerous? Well, it's not dangerous. The thing is that it's just memory is going to be there forever, right? Never going to get cleaned up. So with a weak pointer actually solve this, and correct me if I'm wrong, but a weak pointer can solve this because you're actually not pointing to the pointer, but you're pointing to the abstraction at the weak pointer, which basically does not increment the reference. That's basically what a weak pointer does. So if I'm wrong, please correct me so we can say good things. But that's what I understand in a nutshell, simplified, right? Why is this interesting? Well, for these kind of scenarios, but also, for example, if you have like some kind of a map or a cache, actually, right? And that's what the example. How do you write cache? You have some like a cache with all these pointers. The thing is that the cache holds a reference, so it's never going to get cleaned up, right? But if you have like weak pointers, you can. That's what a weak pointer is, very simplified, right? So you can read this example, because I think what they do here is, for example, they say, hey, listen, we make a new pointer to a blob, and we're going to manually run the GC, and if you run it, man, this is like, okay, needed to boot up a pod or something. So this is going to be value after GC is the same blob. Yeah, yes. I mean, that's logically, but this is an example, because if you have a weak pointer and you run the GC manually, then it's going to be cleaned up. And it's a weird example that actually gonna confuse you. So, but yeah, it is what it is. Weak pointers, think about the linked list stuff and think about a cache with objects that basically are going to keep the reference forever, and with a weak pointer not. Something like that. So very interesting, very niche as well. It's not that you're going to have weak pointers all the time. I would actually do not think about them, to be honest, because right now you're going to think, oh, should I use a weak pointer? Should I use a pointer? Just do not think about them in the normal scope, because it's going to confuse you. But know that they are here if you're dealing with big, large caches and all that stuff, or linked list, or you want to do something like that, where you, for example, in my real-time desktop, by the way, which we can find the link in the description. So if you want to know how I built that, people that follow this channel will probably know. You can find the link in the description. You can join and see how it's made. So we have the same concept there. We have the concept of a chart and a layer, right? And the layer holds a pointer to the chart, and the chart holds a pointer to the layer. So even if it's never going to get cleaned up, you know what I mean? These things. But again, correct me if I'm wrong. So they say improved finalizers. This is a bit above my understanding. But if I read, and I recommend you to do the same, if I read here through this example, it's pretty cool, especially here, this weak map implementation. Weak map is a map with weakly referent values. And there is something you can do. You need to read it. We're not going to cover it because it's a little bit too in-depth in my opinion, but it's pretty nice for the people that are a little bit more low level in my opinion. It's basically a map that clears itself based on the weak pointer if it gets cleaned up. It's pretty nice. You need to check that out, right? Cool stuff. Advanced, but cool stuff, right? Cool. Let's skip that. So here. After many years, the Go team decided to change the underlying map implementation. That's interesting, because that's very brave, because that's normally what they do all the time, right? And they are very, very, very hesitant with changing things that could break stuff, you know? And that's good. That's why Go is amazing. It's now based on Swiss tables. I'm going to be completely honest. I do not know what a Swiss table is, right? I know what a Swiss Army knife is, but I don't know what a Swiss table is. But the only thing I see here is optimizations. And when I see optimizations, I'm going to get happy, right? So you can see that they're going to basically they rewrote their underlying map from the STD. They used Swiss, man, this is such a weird word, I'm sorry, Swiss tables. And you can see that basically access and assignment of large maps improved by 30%. Assignment into pre-sized maps. I think pre-sized is going to be pre-allocated length maps. Improved by 35%. And iterations faster across the board by 10%. That's amazing. It says even 60% for maps with a low load. Right? Large size, few entries. Quote. I think that's amazing. Performance increases is always good to have, right? And that's why I always say, people say, yeah, but Rust is faster and Zig. Guys, listen, I don't think at a certain point of time, Go is so fucking fast that it doesn't really matter anymore, right? Of course, if you're really, really going to be nitpicky, of course, language is going to be faster in theory, but practical, that depends, right? Because you could implement a very slow application in any language, and you can implement a fast application in any language, right? So to be discussed. Let me know in the comments what you think about that, by the way. So the next thing, what they also did is the implementation of syncmap has changed to a concurrent hash tree, improving performance. Again, a performance improved by syncmap. I can remember that in the Hollywood package, the Hollywood actor model framework, which basically also runs on the Market Monkey terminal, real-time desktop shit, so check that link in the description. I was planning to use syncmap, but I wrote my own concurrent map, which is actually very simple. It's just an abstraction around Golang's map, but with a mutex. Syncmap does the same, but it was very slow. There was something very weird with syncmap going on. I didn't really like it, but now they basically changed the implementation, and I can see that they have a performance increase. Check this out for the, how do we call it, the bookworms that want to study the numbers. Be my guest. So, very good. Performance increases. Yes, baby. Directory scoped file system access. The no OS root, that's something that I never actually used. Maybe it's interesting, I think, for people that are worked with these things. Check that out. I cannot basically give any opinion because I have no clue what's going on. Hey. So let's skip that. The benchmark loop, yeah, something you're probably familiar with the benchmark loop for range BN. Yes. Yeah, check that out. Not quite sure what's going on. It's probably interesting. Synthetic time for testing. Suppose we have a function that waits for a value from a channel for 1 minute, then times out. Yes. Reads a value from the input channel and returns it. Times out after 60 seconds. Okay. We use it like this. Go func, we wait here. Val, we read from the channel. What is that? What is read? It doesn't really matter. How do we test the timeout situation? Okay. Surely, we don't want the test to actually wait 60 seconds. Makes sense. Because you can only test it if it basically fails after 60 seconds, but that's going to take long for a lot of tests. We could not make the timeout a parameter. We probably should. But let's say we prefer not to. The new testing sync test package to the rescue. The sync test run function executes an isolated bubble in the new Go routine. Okay. Within the bubble, time package functions use a fake clock. Allowing our test to pass instantly. Yeah, okay, fine. It's basically if you have a function that basically waits. Okay, I see what it is. I can actually use that also for the Hollywood tests because we have a lot of timeouts and stuff. That can basically block the whole tests, and here you can, okay. I need to read a little bit deeper into that because I don't really understand 100%, but I think it's going to be amazing. Check that out. Looks good that they basically implement that because testing with timeouts was a pain in the ass, especially for Hollywood as well. Okay. Test context and working directory. Okay, GG, it's going to be nice. You can read it if you want. Test, discard log outputs. Okay, minor thingy. Appender interfaces. Very niche in my opinion, but could be interesting. It's going to be encoding text appender. Okay, cool. If you make some binary protocol or something, could be interesting. Check that out. More string and byte iterators. Okay, this is very important. It seems minor and people would skip it, but it's not. This is actually big. So, remember Go 1.23, where everybody was basically saying iterators suck. Yeah, they do, because why would you implement an iterator? It's just like, why? Right? It's complexity that is actually not needed. But when it's super handy is when you use a package, external package, that has an iterator implemented. Then you're very happy. To implement it yourself, it's going to be very pain in the ass. Well, pain in the ass. It's going to be just a little bit over the top. But if you use an iterator from somebody that actually created one, you're in a good spot. For example, here. And that's what you actually do. So they first introduced iterators in 1.23, and now they are slowly implementing these iterators in the standard library. People from packages will also slightly but slowly adopt these iterators in their packages, and at a certain point of time, writing Go will be super amazing. For example, here. You have this string, 1, new line, 2, new line, 6. So you want to, for example, you want to basically loop over new lines. What you need to do before this is basically, you need to split it on a new line, append everything into a slice, and then basically loop over the slice, and then do your thing. That's the Go way. It's actually not a big of a deal, but it's still just nasty. In other languages, you have all these cool functions you can call, map and all that shit. But here, they actually implemented an iterator in the strings package where you could just do something like for line in range string.lines, this string, and then do your stuff. It's super amazing. I think this is actually super, super big. Let me know what you think about that. This is actually crazy. The same thing goes here. You have this, I think this is a hyphen, right? So you have this dash or hyphen, I don't know, and you want to split. Right as of today, you need to basically split it on this dash, append to a slice, loop over the slice, and do your stuff. And now you can just do range strings.split split sequence, and then you put in this thing, whatever you want. Could be a semicolon, could be whatever. It's amazing if you make parsers or whatever. Okay, split after, some helpers, more good stuff. So can you imagine that people are starting to interrupt this into their, implement this into their packages, right? So for example, let's say you have some kind of a calendar package where you can just iterate over days, or iterate over months, or over years, or over seconds, you know? Instead of constructing that yourself, you could just, for month, in range months, in years, years.months, for example, and then do your stuff with all the months. That's basically where they're going to, right? And I think that's amazing, right? Super cool stuff. SHA-3 and friends, well, some cryptographic stuff. I don't know what this is going to be. SHA-3 and friends, read if you want to have friends. HTTP protocol, set HTTP1, okay, cool. We're going to skip that. Omit Zero values in JSON. This is actually also very, very, very big. How many times did we make an API? And we built probably, like you and me, we built a shit ton of APIs in Golang. And there's always something from your database you want to marshal, right? You don't want to create a new struct. You want to just marshal what you have, and you're going to do omit empty, right? But the problem is that omit empty omits empty values. The thing is that this time.time, if time.time is empty, you're going to get this. This is an empty time.time, which is nothing. It's empty, but it's going to be defaultly initialized because that's what Golang does, right? If you have a number that's actually empty, but that's going to be 0. So it's not empty, you know? So it's going to be marshaled. And that's super annoying. So what they did is basically, we're going to... took way too long. Let us be honest, this took way too long. They have the omit 0. After 10 years, they finally figured out they could have an omit 0, which basically means that if this value is initialized to its default value, for example, birthday, time.time, this crazy thing here, it's going to omit that because it's 0. Technically, it's not 0, but it is 0 because it's the default initialized value in Golang, which actually is 0. It's complex, but it is what it is. So, and that's amazing because now we don't need to put things in a map, delete this key, marshal it to... No. Now we have this. We can just say omit 0, call it a day, and ship. And sip margaritas on the beach. You know what I mean? Yes, and it has some S0. It's nice. Some abstractions, some helpers. Cool stuff, man. Thank you so much, Go team. The next thing, random text. This is a kind of a bit of a minor thing, but still, I mean, rand.text. You see, they are starting to implement all these quality of lifetime improvements. And I'm really big of a fan of that because rand text actually is going to... Let me run this. Man, yes. Okay, so this beautiful string. So let's say you want to make an ID or you want to make some random stuff. What you needed to do right now is you need to allocate a slice. You need to allocate an array of bytes, right? Let's say 32 bytes, and then you need to rand read into this byte and into this byte slice or array, I would say, if it's allocated. So, and then you're gonna have some bytes, and then you convert that to a string, and it's gonna be all Gucci. So right now you don't need to do that. Now you can just say rand.text, right? Would be nice that you... How long is this text, right? That's the thing. They should have a parameter here where you could say rand text 25. It's going to give you 25 bytes, you know. But hey, it's already in a good direction. This is cool stuff. I'm definitely going to use that, right? And then you have some tool dependencies. I'm not quite sure what this is. You should read that to add a tool. It's too complex for me. This is big. JSON output for build, install, and test. So let's say you have some kind of a SaaS application that builds Golang thingies and schedule them on a server, something like a, how do you call it, like a coolified thing. And the thing is that if you build or test stuff, you're gonna get these outputs, right? And it's very annoying to parse this and represent that to the user in some kind of a dashboard. So what they did is basically right now you can do go test or go build or go whatever dash JSON, right? And this is gonna give you the exact same output but with JSON. So, and that's pretty nice to basically just grab and put into Elasticsearch or something and present your users or present yourself or your QA or your DevOps or whatever, or yourself, a nice representation of what's going on. I like this, right? I like this. I'm going to be honest, I'm really look forward to 1.24. This going into the right direction. Iterators are getting adopted, which is amazing. However, it's 10 years. They could put a lot of these things already into the language. Are they really listening to us? I'm not quite sure. But the thing is that maybe it's good that they don't listen to us, because Golang is compatible. Like, it's so illegal. It's always compatible with everything. That is crazy. So you can even have a project from 10 years ago just gonna run. And that's not in every language. Basically, I don't think it happens in any language at all. And it works in Golang. And that's amazing for that. That's why the language is cool. But that's also why they need to keep things small, concise, slow, and well thought. Right? So, like I said, guys, this was it. I'll really like it. Looking forward to it. Let me know in the comments what you think about that. And as always, thanks for watching this video. And I'm looking forward to see you in the next one. Peace and love.